and share my screen. And let's open the elbow. Starling engine, there we go. And CD mount. And admittedly, mine is not that good. I would kind of hope that you guys do better than this. Okay, so I've got a body of revolution, which is that. I've got a boss extrude, which is that. And then I just shelled it out.
Oh, yeah, okay.
So, I mean, and I'll have to get you some measurements or something. You know, this could be smoothed out right here, this edge. Admittedly, I just drew this really quick. Like in here, there's some pipe stop little bumps, so you can't shove the pipe in all the way. Same way up here. You probably should have those. But other than getting the dimensions better, that's all I'm looking for.
Okay. Also, for the wires, do we need to
Yes.
draw them with all of the curves and twists and whatnot, or do we put those in assembly?
No, absolutely. I want to see every last twist, bend, everything.
So the assembly doesn't alter any of the parts.
So there are some things that we are going to modify at assembly, much as if you were doing a weldment.
Okay.
But
if I
all of the wires should be bent on the table and then get slipped over and installed. So you're not going to bend the wires at assembly.
Okay.
And
what else? So like would the Coke cans be cut, or you'd model a cut can?
okay, so all of that is spelled out in the project requirements, and let me show you how my cans are done. Yeah, go away. So what I've done is I brought a whole can right here into the assembly. Shut up. So here's my whole can. I bring that into the assembly, and I do features at the assembly level. This is very much like when we were grinding blades and vanes at Pratt & Whitney. So at the assembly level, I cut the top off, I punch this hole in, and then it gets a new part number or part name. Very much like going from a white casting to a finished casting, putting it back in inventory so that you can send it off to final assembly. And
Okay.
then this bottom can then gets installed in the engine. And yes, I do want to see all the little twisties, little twisty down there. Mine's broken at the moment. But yeah, I want to see the little twisties around here. The twisty on the top. And those are nothing more than sweep along a helix. So nothing you haven't done before. Or haven't seen at least.
Do they have to be twisted, or could they just be a quick loop?
Oh, I don't care. I mean, as long as the thing can't pop off whatever it's pushing on. So if you did one turn on like this wire, this displacer drive wire, fine, I don't care. It's going to amount to the same thing, but
it doesn't matter what style we make, it just needs to be an intact or good design package.
Say again, your internet glitched on me.
So it doesn't really matter which style of engine we choose.
Not at all. You can do a walking beam, you can do one of these. As long as it's not one of the Lamina engines, that's all I care about.
All right, because I looked at some of the instructions for the engine, no, or some of the checklists and requirements and whatnot on the course homepage. And I got to say, some of it went over my head, or I didn't know what you meant at the time.
Absolutely, and we haven't gotten to a lot of it. So as long as you can start off with things like, drawing a Coke can, you probably have a CD kicking around that you can draw. Um, I'll have to get you some dimensions for an elbow. Um, that kind of stuff. That's about as much as you can do right now. And from past classes, that they've always told me that doing the assembly work is the easy part of the course. It's always the modeling and drawing that people just dread.
Okay. I wish I had known all this ahead of time because when I drew up my Gantt chart, I really had no idea how this project was going to play out.
Yeah, that's the problem with doing the first one of anything. And maybe in coming years, what I should do is talk about the process of how SolidWorks starts with piece parts, and then you build assemblies and you do drawings, and da 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 da. Because that would probably make doing the Gantt chart a lot easier for you guys. And when I look at the Gantt charts, I just pretty much said, "Yep, got it. Nope, doesn't have it." Because I know you're not going to get it the first time until you've been through the process. So I'm going real light on that. So, question in the chat, how harshly am I grading the exams? I don't know how to answer that. Um, Unfortunately, that comes with grades. That's like, you know, the subjective answer to how good is good. You know, what do you consider as a failing level of stuff? Um, I will say that as I've looked at it, what I've decided to do is treat all the parts equal. That last part was pretty difficult, that exhaust hanger. So everything has been graded based on 33 points each. That kind of lightened the impact of the last one. Um, Class average right now after the first 15 people is at 79.6. My typical exam one, the average for the whole class, generally ends up like a 75, 79, somewhere in there. And that's been quite repeatable year over year. So we'll see what this one comes out at. So far, I've been quite pleased with the pencil and the way you guys have done the ball. A lot of people got the ball, and I thought that was going to be the worst of them. So
Really?
maybe it's not going
I
to be that bad.
saw the way you drew it, and that wasn't the way I did it, but it made sense.
You
When
know,
when I first,
there are several ways that I've seen people do it, and I'm all good with it. As long as you get the right geometry in the end, don't care. As long as it's not totally off the wall. So you guys probably want to go through that.
yeah, I had to use the whole wizard twice on the pipe because I did the oxygen sensor thing after I bored the hole. And the simplest way to get it trimmed off was just like sticking another hole through there.
Yeah, and that's totally fine. I have no problem with that. Okay, so let's start off with the pencil. So far what I've seen is most people were good with the pencil except for sharpening it. So let's just replay this. So I started off just extruding a hexagonal uh, rod, and then I decided to sharpen mine. And the way I sharpened it was with a cut revolve.
Oh, I was trying to use a line to cut it. That's why it didn't work for me.
And this is all I did. So coming off the center line, I went up 10 thousandths for that 20 thou flat on the end. I went out at 9 degrees. I came up and went around and then back down. And that was it. So this is a lot like the inclined razor blade in a normal pencil sharpener. And then I just spun it around and got a sharp pencil. So yeah, I was wondering how people would deal with this little pattern when really I never drew it. I just sharpened the pencil.
Yeah, that one was kind of funny.
It was a little bit weird.
I actually had to start over from the beginning because I tried to.
Yeah, I saw a bunch of people try to do chamfers on that and stuff like that. One person did a successful extrude, which was quite nice, quite elegant. They drew the tip of the pencil and they did an extrude cut with a reverse direction. So rather than cutting on the inside, it cuts on the outside of the circle. And they put a 9-degree taper angle.
I tried to do something like that, but when I or tried to extrude a hexagon, or extrude cut a hexagon, but it cut out the inside instead of the outside.
So what you wanted to do was extrude a circle, and then it would have worked.
Okay.
Yeah, I struggled with that as well, with the tip. I couldn't get it.
Yeah, it was just a revolve cut of a line, basically.
I tried doing a revolve cut. It didn't work for me, so I just an extrusion moved on.
So I'll be curious to see why it didn't work. I suspect what went on was probably you had an open region.
I had that issue too at first. I
Yeah.
heard someone else say the same thing.
That's the typical thing that people have issues with.
I tried doing.
Though, I should have, as soon as I saw that, I thought I should have drawn a pencil for the day's homework. And really have this down easy.
Well, when somebody said that, I was like, oh, no, you're taking my good example. Because I was hoping that this would be the nice, gentle lead into the test that would be a slam dunk for everyone. And then you'd go on to problem 2 with a calm head. At least that was the intention. Okay, so I put the origin right at the interface between the wood and what's normally the brass band.
Interesting.
So then I just extruded a circle out this way. Put another extrusion on the surface.
Oh, okay.
And then did an edge fillet to round out the eraser.
I did a cut extrude going the other way. I made the hexagon the full length of the pencil, then I cut extruded, I think. Or no, I did an extrusion the other way.
So the only reason that a cut extrude wouldn't have worked well is that the
Right.
hexagon was smaller than the brass band.
No, I think I did an extrusion on the brass band, then I did a cut extrude for the circle, or for the eraser, I think.
And that's fine. You know, as long as you got the right geometry, I don't care. You give 10 designers an object to draw, they're going to do it 10 different ways. As long as the solid model's the same geometry, it's all good. Okay, any questions on that, guys? That was the easy one.
How did you do the pencil tip with a circle?
Revolve cut. No, I was just saying that the circle one was quite innovative. That was an excellent use of a cut extrude. The way I did it was like this. I did it more of a plain Jane kind of way. So I just drew this region
Oh,
and I raised the tip up 10 thousandths so that when I swing this around, it shaves it all away.
Hey, Professor, can I screen
Wow.
share? Because, like, I got that to that part. I just, like, couldn't cut revolve it, and I don't know what I was doing wrong.
Yeah, absolutely. Go ahead,
Okay.
put it up there.
It says the screen sharing is disabled.
I thought I hit it. All right. Nope. All right, try now.
So like I got to here. The one thing I didn't do, like I couldn't figure out how to move it to the right like you had it, but I had the like triangle. And
Okay.
then when I
Yeah,
go
so you were
to
90% of the way there.
like when I extrude cut, I just couldn't like figure this part out.
Okay, so then you don't want to be an extrude cut. You want to be an extrude revolve, or excuse me,
Oh yeah,
cut
yeah. That
revolve.
yeah, that's what I meant. That's what I meant.
Okay, so then let's pick on the axis of revolution.
So I
Click
just
in
did
your,
axis 1 right here.
yep, good.
And it just like doesn't move. I don't know.
Let's see. Go
I'll
down
try
and
going under.
go down and hit selected contours. And now click on the sketch and say OK. Sketch is open, intersecting, or okay. Yeah, this is something that I ran into. You got to have that 10,000 offset or it blows up.
Okay.
So if you get rid of that coincident down on the center line, and just click the green box and hit delete, or that. Okay, so now just move that bottom up just a hair.
Okay.
Yeah, now try and do a cut revolve.
Yeah, now it works. I
Okay.
think.
Yeah, that's all it was. Yeah, I'm not sure why it didn't. I'm not sure why it doesn't like to create an absolutely perfect sharp. But it just kept blowing up on me too.
Okay.
So I took the easy way out.
Thank you.
Yep, no problem. Let's see. Okay. Yeah, Jacob, on your statement with the ball, yeah, we'll work with that. Okay, so let's see. Anybody else have any other questions on the pencil? Anything you want to add, share, thoughts? No? All right. We'll get rid of this and move on. Won't go to that yet. Okay. So, my beloved doggy's little ball.
Mine turned out black with neoprene.
Yeah, I intentionally changed the color of mine because Gracie's ball is orange. So, you know, you got to appropriately color your dog's ball. And I saw you guys do it more elegantly than mine a couple of times. So let's go with the basics. Start off with a sphere. All right, so there was some thought on how do I make a sphere? Well, it's pretty simple. I draw half a circle and revolve it. And so far, everybody I've seen got that much.
Could
Yes.
does it have to be a half circle? Because when I tried to do it with a full circle, it did not work.
Yeah, I got in the same problem too. It has to be half circle.
Yeah.
Okay.
I've never had a full circle work. I would, conceptually, I would think that if you had a full circle and you went 180 degrees, it would be okay.
I think it doesn't because it's two parts. I don't know why it doesn't like it.
Yeah, whenever I do bodies of revolution, I always do a half of whatever it is I'm drawing, and it works fine.
Okay, I'll have to remember that.
Okay. So then, For some reason, I must not have used my template. I had to drop in an axis 1 right up the center. And then I put a tangent plane right on the top, which, you know, had I thought a little more ahead, rather than putting my origin at the center of the ball, if I just moved the ball up, I could have used the top plane to do all my other sketches on, but okay. I dropped the tangent plane right on the top. From there, I did a cut extrude and I cut the little wedgies out of the side. And it certainly doesn't have to match what I did. You could have 4 boxes there and cut the wedges out with 4 boxes. That would be completely fine as well. Or you could do 1 wedge and do a circular pattern around the center axis. Again, totally fine. Somebody did that. I thought that was quite elegant. So you cut the wedgies out and then just revolve another ball in the center. And then lastly, the fillets. And that's it. That's all there was.
Wow.
This one was, in my opinion, the most conceptually difficult problem of the entire test.
Yeah.
I think that was the easiest.
Really?
Yeah. Until the point when I asked you about the 2 parts, the second part was the second sphere and the inside. Up to that point, it was the easiest one.
Huh.
I was thinking that I needed to make the inside ball and then put another plane and then do the whatever it's called, something along the line, sweep along the line. I thought I had to do that.
So I saw one person who did a really nice job. They did the cross section of this rib up on top and they revolved it around this way and then it revolved it around the other way. That was very elegant too.
Yeah, I did something like that, but mine just like came out funny, like when I did that.
Yeah, I also had a bunch of people who drew like a circle with just, let me see, that edge. They made it a full circle, however, and extruded it. Okay, which I kind of had to ding them pretty hard because they didn't get any of the curvature on this face. They got something flat that didn't match the print. And then they got some weird contours up on the top from it. So, good attempt, but no, it didn't get there. Okay. Anything else you guys want me to tell you about this? It was really just cut the wedgies and put a ball in the center.
Could you please put up the drawing of it? Because I messed up a little bit. I forgot to put the inner sphere in. I didn't see the part where it said the inner sphere.
Sure, absolutely. Okay, so in the top view, you can see the inner sphere right here. That should have been the giveaway. And then in the front view, you see another sphere.
Yeah, I kind of see it with the fillets in the front now. And other than that, I did pretty good on it, but I just forgot the sphere. I didn't see it at the time.
So I've been trying to like equally weight the features in each part. And that's more or less working well, depending on whether people had it conceptually right or not. Okay. So any other questions on the ball?
Nope.
Nope. All right.
The biggest issue I had with this piece was the cosmetic threads. I'd only really done it once before on that nut, on the bolt, and
Yes.
could not remember where to find the command.
Yeah, that's always a problem.
It just didn't have enough
Unfortunately,
time.
there's only so much homework I can give you guys to drive home this stuff. So as I'm looking at this even now, I realize that there are more efficient ways to draw this than I did. But let me go through the way I did it. We'll talk about what could be different. Okay, so I started off, I drew a rod. And then right off the top plane right here, I put another sketch on that. I drew a circle out here and extruded the boss up for the O2 sensor bung. I put plane 1 in where I knew I was going to do a sweep. Put plane 2 in so I could put in my guide curve for the sweep that was going to become the rod. And I did my sweep. And one of the things that I've seen a couple people do, they just read the print wrong. So it should have joined up into a straight line right here. And that was a problem for some folks. They saw it as, I think, 1.188, and it should have been a little less, so it joined up. That's not the kind of thing I'm going to ding real hard. That's just blueprint reading.
Would you go over the sweep of that circular piece just so it comes out in that hook pattern at the top?
Sure. So I did it probably the hardest way you could do it, unfortunately. The better way to do it, in fact, I'll just let the thing blow up right now. Ah. So what I did, what's causing me problems at the moment, is I used this curve, this guide curve, to locate the circle. See if I can get rid of that. No. Let me just reopen this. What I'm going to show you is what I could have done is just use the guide curve along here, and under the sweep function there's an option to just say give me a circular body around the guide curve, which absolutely would have been the better way to do it.
Okay, so the sweep function is how you did that.
Yes.
Okay. And with the fillets between the hook and the tube, which were supposed to represent welds, I had some trouble getting those in, but I'm pretty sure that was just because the circle wasn't
Joining up.
It wasn't right. It wasn't joining up. It was
Right.
maybe hovering slightly above. Although I am still a little confused about why I had the same issue with the or a similar issue with the O2 sensor bung. I'm curious as to why that wasn't functioning properly.
Now I did see a couple of people that came in and they put tangent planes right on top of the pipe, and then they drew a circle, and there was an air gap between the sensor bung and the pipe. So if there's an air gap in there, then a fillet's not going to close things up.
I had made sure that the bung extended down into the tube before I drew the hole for the tube. So there was no gap there. Like I had said during the exam, it was trying to put the fillet inside of the circle for the bung. So I'm not sure why that happened.
Okay, so the most typical reasons that'll happen is the two bodies are like tangent to each other and don't share an intersection edge. Okay, so that's one. The other thing that could be going on is if you have, say, this is your first feature and this is your second solid body generating feature. If you don't have merge results turned on, and that is right here. Okay, so under my second boss, I have merge result. It's on by default, but I have seen people not have it turned on. So if you've got two distinct bodies, you will not get a fillet between them.
Okay, I see. So if I were to turn that on and then try that again, that would probably work
solve it. Yep.
Okay, thank you.
At least those are the first two things I'd go looking for.
Can you tell me what merge results doing?
Yes. So in many CAD programs, there's something called a combine or a union command. And what it does is it takes two distinct bodies and fuses them into one body after the operation. And that's what it does.
Gotcha. So what was happening with that not being on was that the O2 bung coming up and the pipe were still considered two separate entities, and it didn't know where the heck the fillet actually went because of it.
Yep. Yeah, I'm not sure how that gets turned off. I have never seen it get turned off on any of my editions of SolidWorks, but for whatever reason, I do see it turned off in some students' editions, and not uniformly. So it can be an issue. Okay, so this hook was a sweep, and all you really needed was the guide curve. And then you could just click on it, put in the diameter. It should have joined up if it was properly drawn, and you'd be good to go. At that point, I put the hole in my pipe, filleted the O2 bung. I gave you guys this M18 by 1.5 tapped hole. I was a little bit worried that it might have been too much of a curveball, but really the only thing you had to do with that is you had to know to come over to straight tap for where all the other tapped holes are, ANSI metric, tapped hole, and just choose M18 by 1.5. And at that point, just accept all of the defaults. So because it was just clicking through menus on known stuff, I thought, that's not horrible. Okay, so then another fillet. This is one I forgot to put on the print. This one right here. And that's how I got the next fillet to wrap right around the front edge. I am absolutely not taking off for that. So if you don't have a nice smooth transition right in here, totally fine. So hopefully you guys remembered that I always do fillets and chamfers as the very last things. So hopefully you got all the major good geometry, and then a fillet is like nothing. It's a couple of points maybe. And then the last thing I did was a little chamfer right up here. So more steps, but none of them were really horrifically difficult. Probably remembering the external thread one, because we didn't do a lot of them, was probably the worst of it.
So you put the hanger on and the bung, and then did the cut extrude for the pipe?
Yeah, I'll run you through it quick. So take the blue bar, go up, solid rod, bung, sweep for the rod, hole down the center, fillet the bung, hole through the bung, break the edge right in on the end, weld fillet for the rod, and then chamfer. And that was it. Questions on that, guys? I mean, it was a lot of stuff to remember, but no one piece was all that brutal. Okay, so we got 20 minutes left. What else would you guys like to know about?
What's the homework due this weekend? Which lessons?
So you got to do the soda can and the 2 objects from your dorm room or wherever you live. You get that, and I think that's it. So on the 28th, yeah, you just have lesson 7. That's the caliper lesson. You didn't have any homework assigned because of the exam. So soda can and 2 ruler measured parts.
Do you want us to add a material on our 3 sketches?
I mean, sure, as best you know it.
Okay.
I mean, you're probably going to have polystyrenes, polyethylenes.
Is it 3 items that we're measuring or 2?
So it's going to be a Coke can and 2 other objects.
Okay.
Anything else, guys?
Do we get extra credit if they're really hard?
Yeah, that extra credit is.
Yeah, do we get
I like
extra
that.
credit period for the
All right.
test?
So I got to see. I'm still figuring the test out. I'll be honest with you guys. So like, at first I was going to do more heavily weighted on the last problem because it had the most features. But then I was just finding that that was doing too much damage to the grades. So then I just said, okay, 1/3 for everything. And that made things a little more manageable. The next thing I'm going to do is I'm going to go through, grade all of the first section submissions, find out what the class average is. Okay, I don't know what's going to happen, but some of the things I'm toying with are, I could just take the exam and just throw it away. Just get rid of it. Say we're going to have another one. I know that thrills you guys
I
to the
vote for
core.
that. I vote for
I
that.
would go for
I
that.
also
Yeah.
vote for that.
Yeah,
Yeah,
let's-
but you don't know what awful thing I could pull out of the barn.
I'll be
True,
ready for the
true.
next
You
one.
can make it. You can make it.
I don't
10
care what it
times
is.
yeah.
Well, I wouldn't go that far, but
Oh,
Yeah.
I don't care. It can't get any worse.
There's
It can't get
ugly
any worse.
stuff out in the barn. So anyway,
not
that's,
uglier than anything I drew.
that's one option. Because at the end of the day, I mean, you guys just have to know this stuff. Because it's going to come back to haunt you. You're going to use it in other classes. You're going to use it out in the world. So you just got to know it. So I really don't feel like I can just say, well, I'll throw a curve at it and everybody goes up 50 points and passes and great. No.
I think we learned enough through that exam. So we can take something harder if it's for extra credit.
So anyway, whatever happens, I got to get to the point where whatever grade you have is in some way, shape, or form a proper reflection of what you know in your head. And it's not going to be just play with the numbers. So on that note, that's all I got, guys, unless you have questions or stuff you want me to go over.
I do have one question on the third model.
Yeah, absolutely. What would you like?
Could I just had some issues just finding the proper thread for the bung the 8 by 1.5
Yep.
thread.
So what I was hoping would happen on that one is I just wanted you to come over to the hole wizard and go right to straight tap. It's a threaded hole, so immediately I hope for straight tap. I told you it was an 18 millimeter metric hole, so I expect you to come down to standards and just go metric. And then on the next one, it's not a pipe tap, and if you chose bottoming tap, okay, fine. You'll still get the proper thread. But tapped hole was really the appropriate one there. Then if you come down to hole spec, here's all the different hole specs. And I was hoping you were just going to pick M18 by 1.5 right out of the list, because that's what it said on the print. You click that. And I don't even really care what you fill in here. I do care that you have cosmetic thread turned on, because I told you I always want to see the cosmetic thread. I'll say okay. And then as long as I can rotate your part and look down inside, and I've got a nice clear hole to put my sensor in that goes down to the gas path, I'm good. That's all I want.
Awesome.
It's just got to make logical sense. I did see one person get balled up. They put an M18 by 1.5 helicoil thread in, and I kind of had to take off a couple of points for that. A helicoil is something they use for thread repair. So let's say that I took my O2 sensor out, I go drag racing, I get a bunch of rocks up in the threads and destroy the threads. I could come in, drill it out, tap it with this helicoil tool, and then screw in a brand new M18 by 1.5 thread as a repair job. That's where you use helicoils. Normally, however, I just wanted M18 by 1.5.
All right, thank you.
Yep. Anything else, guys?
How do you go about preparing for like these exams? Because I feel like when I do like prepare for a physics exam, I'm able to like work problems that are going to be similar. But when I do these, I feel like I'm starting from scratch. Like I have no idea where to start.
So the best thing to do would be to go through all of the old exams, which I was kind of hoping you would do. And those are all under lessons. And my old exams for practice. These are my lessons for the last 5 years. So like, and some classes I've gotten further than others. So like in 1 year, I told the students, I want you to draw this part 3 ways, this little seatbelt clamp. So they had to draw it as sheet metal, they had to draw it as an extrusion, and they had to draw it as a sweep along a guide or something like that. That was kind of a hokey question. I didn't use that one again. And I actually never reuse test problems. I figure they're all going to end up in a dormitory file cabinet, so why bother? This is actually a piston out of a Willys Jeep. Hard to imagine I would use that. That was a pretty good problem. It's got some linear arrays in it, stuff like that. Canning jar, that was kind of nice. I think I did materials early in that one, so they could actually draw a glass jar. That was kind of a simple shelled part. Again, this year I got through sheet metal, so they got to do a sheet metal electronics enclosure. This is a good one. I almost always have something like this little shaft adapter. So I've got a circular feature pattern. I've got some hole that you have to put on a curved surface. Almost always have one of those. And then it's all on a body of revolution. This was a really good one. I like this one a lot. So this is my trailer hitch. This was nice because they had to extrude the tube, put in a mid-plane, and then draw the ball on a mid-plane. Then you revolve half of the ball around. Here's the pin that holds the ball in place. Again, this year I got the sheet metal before the exam. So there's the belt guard off my lawnmower. And next time we get together, we're doing sheet metal, so don't feel like you guys are missing out. This is one where I went to the hardware store and got the exam. I got this nice little anchor shackle. Folks did quite well with this one. I was surprised. This could be a little bit hard. Another lawnmower belt guard. Locking shaft collar. This one wrecked the class. They had an awful time with this thing. It's got a helical cut in the part, and they just did not know what to do with it. I ended up throwing this problem out, grading the other two. And it's not terribly hard. Huh, I'm missing one. So I had one year that I also had them draw a padlock and something else. I'll have to go find that. But I'd like to think if you went through all those old exams and you could do all that stuff, minus the sheet metal, you'd be in pretty good shape.
Thank you.
Yeah. Other questions before we sign off, guys? Got 10 minutes.
Yeah, I'm having like a hard time putting the hanger on the exhaust.
Okay.
Do you mind if I share my screen real quick?
Yeah, go for it. It's all yours.
So I like have the plane in and everything. Is that
okay? Perfect.
Yeah, okay. So I was just like, how do you get the sketch to line up with the exhaust?
Okay. So I'll take the screen back. I'll blow away everything except to that point on my model, and I'll show you.
Okay.
See, we'll get rid of the sweep. Get rid of that. Okay, so that puts me right about where you are. So on my plane one, I'll click on it. I'll click on it. I'll do a new sketch. I'll align to the sketch. And the way I would do it if I was going to draw it again is I would start off by coming in here. I'll draw a circle. I draw a line. Oh, come on. See, I'll draw another line from the center. I'll make this construction. And let's see, we'll trim it. Set this at 45 degrees. And this is actually really good because then I can show you guys the simple way. Okay, so there's, minus the dimensions, there's the center line of my rod.
Okay.
And now what I can do, I'll do a swept boss or base. I've got sketch 9 selected. I'll do circular profile and a diameter of 375. That would have been the smarter way for me to do the sweep.
How did you do that?
Okay. So I've got my sketch.
Yep.
You good with all that, all the steps in that?
Yep.
Okay. So you come up to swept boss or base. I'm going to click on just the guide curve. And up on top here, I have circular profile because you do so many of them for brake lines, hydraulic lines. So I'm going to choose just a simple circular profile. Then below it, I'm going to enter the diameter of the profile that I want. Excuse me, the diameter of the rod that I want, 375.
Okay.
So now if I go back into sketch 9 and I put in all the appropriate smart dimensions, it will bring that curve and this right down to where it should be. And it'll all join up.
Okay.
Yeah, so I think the big thing on sketch 9 was that one should have been 1.180. I saw a lot of people put 1.188, and that was causing things to not join up. And now when I come in, yeah, you can see it's got that little line right there, and it joined up. And if I fillet the thing, I don't get it to come around the front edge right here real nice, but I don't care about that. I'm not taking off any points for that because I didn't dimension this edge break for you guys. And then I could have gotten rid of this plane. I could have done a lot of things simpler. But that's an easy way to do the rod.
So what was the dimension between like the circle where the hanger goes and the actual exhaust?
So I put an overlap of 8 thousandths. So right here, this radius of 1.180.
Okay.
And the center of this guide curve is centered on the pipe.
Okay.
And while we're here, almost everybody has gotten the thread on the rod wrong. They go and put a hole in there. So I've been repeatedly writing snarky comments about if you drill a 3/4 hole in a 3/4 rod, you end up with no rod. So just doing that doesn't make sense. So if you want to put a 3/8 thread on this, it's simply insert, annotation, come over to cosmetic thread, click on the edge. It chooses the most likely thread based on the diameter. And since it's exactly 3/8, it knows 3/8/16. Blind simply means to a depth, and I told you thread it for 1 inch. And that's it. That was what I wanted to see on it. So the other thing that was kind of the giveaway on that one is if I had drilled a 3/8 hole into this 3/8 shaft, I would have seen the dimple of a 118-degree drill bit right in here. Because you didn't see that, kind of should have told you, well, it's probably on the outside.
Okay, thank you. I gotta go.
Okay. Any other quick questions, guys, before we sign off?
I just got here late, but you did like drill the center, I guess, of the pipe.
This one right here, the M18.
No, the like actual exhaust pipe, not the exhaust.
Oh, yes, yes.
Okay.
And in my model, that's right over here, this 1.875 diameter pipe hole.
Okay.
Any other questions, folks? And I will post the video for this office hour session.
Thank you.
Okay.
Thank you. Thank you.
Thanks, guys. Stay tuned. I will be in touch with grades. Good night.
You can keep them.
Yeah, somebody got a question out there?
Yeah.
Yeah, Adam.
I need to know when it's time to throw in the towel for this class.
It's never time to throw in the towel. Let me take a look at your stuff. Let's see, we're the only ones on. Let me stop the